Welcome to ClickMyProject.com.
Now we are going to discuss about the product detection of AF in compressively sensed electrocardiogram measurements. Now we are going to discuss about the abstract for the process. And ECG is an important diagnostic tool for the assessment of several diseases. In this process, we have implemented the machine learning technique based on the random forest framework, that is the name of the algorithm, which is used previously trained on the generated general signal data is transferred to carry out the automatic ECG diagnostic by classifying the patient by using the ECG signal into an corresponding cardiac conditions. On the other hand, the main focus of this process is to implement the simple, reliable as well as the easily applicable machine learning technique for the classification of the selected signals from the datasets. Actually, the dataset consists of the several signals, both the ECG having the normal as well as the abnormal. The resultant demonstrate that the transferred deep learning classification cascade with the convolutional back propagation neural network were able to obtain the very high performance rates. The performance of the parameters will be estimated based on the suitable parameters we have estimated in this process. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. At first, the input signal is taken from the dataset. The dataset consists of both the signals of the normal as well as the abnormal. After getting the input signal from the dataset, the signal is gone for the pre-processing. In this pre-processing step, we have two kinds of steps. One is the limit the signal as well as the another one is the noise filtering. So the signal limiting consists of we have to limit the n number of signals into one particular ranges. After the signal is limited, the noise filtering is done to remove the noise present in the signal. After the noise removal, the output will be in the form of noise-free signal. After that, the third module is the case-pass segmentation. Hence, in this module, we have done the compressive sensing algorithm to extract the corresponding data from the signal. After that, we have done the feature extraction. Feature extraction is nothing but the collection of some other data from the signal. So here we have using the 6 types of feature extraction methodologies. The first one is the peak detection, then the second one is the RR interval, then the third one is the EMT, then the fourth one is the DWT, SWT, at last the final one is the DCT. After extracting the features from the signal, that will combine to form the test feature. After that, finally, next to the feature extraction, the classification will be done by using the random forest algorithm. Hence, in this classification steps only, we can judge whether the input signal is normal or abnormal. After the classification, the performance will be evaluated based on the accuracy, sensitivity, and specificities. Based on these three parameters only, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015B and change the current directory. Now we can see the file in the name of main_page.m. Right click in that file and select the option Run. Now the initial user interface was opened to start the process. You can see the button in the name of Start Process. Click this button to open the new user interface. Now in this user interface, there are several push buttons in the right side and then the several axes in the left side for the controlling process. First of all, click the button Input Signal. After clicking the button Input Signal, the datasets will be displayed. Select any one signal from the dataset. After the selection of the signal from the dataset, the corresponding signal will be shown in the axis 1 with the title Input Signal. After getting the input signal, we just move on to the second step, that is the pre-processing. In this pre-processing signal, the This signal shows the limitation of the signal. This signal shows the filtered signals. So hence, after getting the filtered signals, we move on to the feature extraction. In this feature extraction, the peak detection, RR intervals, EMD, DWT, DCT and SWT features are extracted, and then the corresponding values will be displayed in the each and every tables. After extracting the features from the signal, we just move on to the classification. Click this button for the classification. Hence the new GUI will be open. In this, you just click the button classification. Now the classified result is shown here. Hence the classified result shows the signal as a normal. And one more thing, this figure window shows the test feature, train feature as well as the result of the classification. After that, finally, we just move on to the performance. In this performance, we just evaluated the performance parameters like accuracies, sensitivity and specificities. The values will be shown here as well as the corresponding values will be plotted like a graph format. Thanks for watching this video.